A very good afternoon to everyone. My name is Anand and I am welcoming you all on behalf of Solar Quarter and First View Group. Our today's conference on PV mounting tech, structure and tracker technology forum has brought all of us together on this virtual platform to have insights from some of the prominent industry leaders representing various segments who are actively involved in driving solar mission forward in the region. Hope you had a great time networking with your peers in our exhibition launches. If you have not visited yet, you are definitely missing an opportunity. However, the booths will be open till 6:30 p.m. today. So, now requesting my team to please play the sponsor video. Thank you. So, before starting today's proceedings, I take this opportunity to thank and welcome our partners for this event. Our platinum partner, Stroller. Stroller is India's leading mounting systems company with 2 gigawatt of mounting supply in India, the Middle East, and Africa. Additionally, Stroller is only mounting system company in India to supply 1 gigawatt rooftop mounting system in India. Stroller is India's premium mounting system company for commercial and utility scale rooftop and ground mount PV solar plants. Its in-house design team and dedicated towards new product development for solar industry. Stroller has emerged as a leader with best-in-class product available in Indian market. Thank you for your support to this event. Another partner, industry partner, Sir Energy. Sir Energy is a renewable energy engineering consultancy that was founded in year 2002 in UK and has spread its project presence in over 40 countries worldwide. With a center of technical excellence located in India, Sir Energy has a rich and diverse experience of working over 68 gigawatt of projects worldwide. Sir Energy has recently announced a new chapter, Sir Energy Arabia, in Riyadh, which will be the headquarter for the MENA region. Operation in Riyadh will be catered towards the MENA region and will be headed by Dr. Khalid, an electrical engineer with over 3 decades of experience in renewable energy sector. So I thank our partners for their support to this event. Now, without further ado, I would like to invite Mr. Varun sir from S1 Tracker Private Limited to give his presentation. Varun sir, welcome on the screen. You can please share your screen.
Is my screen visible to all?
Yes, sir.
Okay. Good afternoon to everyone. My name is Varun Sachar, and I am the owner for ASEN Trackers Private Limited. And the ASEN has got various other companies, all in the domain of solar. We are into rooftop. We have got our assets on solar as well. So let's come on to the point, that is the solar trackers. Let me start with a quote by Einstein that imagination is more important than knowledge. Knowledge is limited, imagination encircles the world. So that's the thought on which I have worked upon. So let's talk about the growth of solar, which has been incredible over last, you can say, 5 to 10 years world over. The big factor in this increase adoption has been the constant development in technology. It has been being a very dynamic industry, and where the panel cost reduction has been there, which almost contributes to 60% of the project. Now, these improvements is not only happening, the improvement has not only been happening in the solar panel, but also in the inverters. Now, these improvements are there to continuously check on reducing the levelized cost of energy, which is everybody's concern, and increasing the project IRR. So every panel manufacturer and inverter manufacturer focus is on the above two factors, that how to reduce the levelized cost of energy and how to increase the IRR. So everybody is working on this concept, whether it's a cable manufacturer or it's a structure. Now, along with this increase in growth and resulting in competition, there has been a steady fall in the tariff of the solar energy, which is happening world over. This has resulted in cost optimization with focus on the BOS. However, it has reached a plateau today. The only way forward is a closer look at operational efficiencies. That is, the CUF, the capacity utilization factor, remains the single largest factor in the competition play for the developers. So everybody wants to continuously increase the yield, and the only way to achieve higher yield is by increasing the CUF, and that improves your IRR. One area got missed out by the industry, though everybody focused on module, modules, inverters. MMS was ignored, on which the life of the plant depends. So a life normally which is for 25 years, so MMS has to be very, to be very strong. So let's say that how to maximize the yield is the how effectively and efficiently we are harnessing our only sun. That is important. And here structures, the MMS plays a major role. But before that, let me try to go back to the basics on the basics of this technology. We know the sun path, that during summers, which is depicted by the red arc, the sun moves from east to west. There is no dispute on that. But when there is a season change in the season, when it moves towards, you mean to say, towards the winters, the sun also moves towards south. But the movement from east to west remains there. So the amount of electricity generated of the solar PV module is maximum when the angle of the solar incidence on the module is perpendicular or at normal. So we all know for the fact that it has to be at right angle. The angle of incidence has to be there at right angle on the module. So what are the prevalent options available with the developers or the investors world over? Is the fixed tilt. You mount a module on your structure on the MMS and allow the sun pass from east to west, and the angle of incidence is never maintained at 90 degrees throughout the day. It is only at one particular time in a day, when the sun is right on top, will will make an angle of incidence at 90 degrees. But how about when the winters fall in? There, the angle of incidence is again not maintained. It becomes at more of an acute angle at that stage. So it is the performance what you get from the fixed tilt is suboptimal. The second option which is available, which everybody in the industry has been following, is the single axis tracker. Undoubtedly, the technology has been there for so many years, and these are horizontal mounted single axis trackers where you can see which only rotates from east to west, and it is only effective during summers. How about when the sun is moving from north to south? That is, the angle of incidence is again not maintained at 90 degrees, it is falling at an acute angle. So there will be a short in the energy during winters. The third option which is available, which we all know, is about the dual axis tracker, undoubtedly the best technology which is available, and it follows the sun path from east to west, north to south, northeast to southwest. So all these directions it is moving around. So I should not call, I will not, I would like to rename this technology from dual axis tracker to multiple axis tracker. Well, that's not, I can't do on that, but yes, that is what I would like to do it. So this technology is there in the market, but economically unviable for any utility scale projects. It is only good for captive use. So because of its high capital cost, high structure weight, it is not being used in the utility scale project. So keeping this into mind, all these three different structures, we have designed a two-axis solar tracking system where we say that the performance is close to a dual axis tracker and a single axis tracker. And how it is being done. So what are we calling it as? An ASIN two-axis tracker. And this design has been done in collaboration with Indian Institute of Technology, Delhi, India. And it overcomes the inherent disadvantage of the single axis tracker. And it also addresses the key investors or developers' concerns that, that prevent adoption of trackers, because people have been avoiding using trackers because of various factors. So our technology is very simple, that each and every module is moving from east to west, and the entire table moves from north to south as the sun moves from summer to the winter position. In between, it passes through the various solstice period, that is your summers and your autumn do fall in between. But the angle of incidence is always tried to be maintained at 90 degrees. So what we did before we go into the market with this technology needs some validation. So we did this validation at our own plant.
Votre correspondant est déjà en ligne.
We did this validation at our own plant of 2 megawatts. On the left hand side, you will see a fixed tilt installation. On the right hand side top, you will find a horizontal mounted single axis tracker. And in the front is the two axis tracker. So we picked up the generation data on day-to-day basis, and to our surprise, or rather it was to a pleasant surprise, we got this data. The graph which you are looking at is the orange, sorry, the gray line is of the fixed tilt, and the orange which you see is of a single axis tracker. So in month of October, November, December, January, and February, the performances either are at par with this fixed tilt or it is below than the fixed tilt. The generation is only happening during the summers. Whereas two-axis tracker, when it is following the sun path from north to south, the generation you will see is in blue line, which is all above the other two graphs. And the generation what we got is 20% over the fixed tilt and 13.5% over the single axis tracker. So if I have to translate into a different one, that is single axis tracker gave us a performance of only 6.5%. The location here is the northern part of India. Northern part of India, which is above the Tropic of Cancer. I'll come to that point in my next slide. Same graph I'm trying to show in a bar chart where we have taken the fixed tilt performance as delta, and the orange is the single axis tracker, and blue is the two axis tracker. So this clearly indicates that in the month of February, October, the performance is almost at par, whereas November, December, and January, the performance is below than the fixed tilt. I think I made my point clear on this. We did some simulation, uh, on the global basis, and we picked up the third-party software, which everybody is using it. So we also use that same software to do some simulation on two-axis tracker as well as on single-axis tracker, and you can see here very clearly the two-axis tracker has been performing consistently well across the globe, whether it is on the equator, below the equator, or above the equator, whether it is above the Tropic of Cancer or below the Tropic of Capricorn. Single axis tracker has only performed when it is close to the equator. Middle East is one region which is like 80% is falling above the Tropic of Cancer. So two axis tracker is highly recommended and the best solution available. Where we have, I think we have given some simulation for UAE, where single axis has performed 12%, two axis 22%, Egypt is 12% and 20%. This all depends on the variation. So our technology, if I have to put it this way, is uniform across the globe. Now, the design. The design is so optimal for a bifacial module, which has been the latest technology in the solar module. So two-axis tracker, a unique panel configuration gives you better bifacial module performance as compared to any other tracker design. The first, pictorial on your left-hand side, you see the gap between panel allows more radiation to bounce off the ground below the tracker. And on the right-hand side is the radiation reflected off the top surface of one panel can be captured by the bottom surface of the next, the adjoining module. So bifacial module will give you much better results on this particular design. Thank you. Thank you, Anand. I think I'm through with this. So any questions? Anyone has got any questions,
Thank
or
you.
we would like to take it later?
Yes, sir, we have a question answer session at the end.
Okay.
So, yeah, you can stop sharing your screen, sir, and thank you for this wonderful presentation.
My
Uh,
pleasure.
Now we will move forward with our much awaited panel discussion. The topic of our panel discussion for this session is structural engineering trends and latest advancement in tracker-based mounting structure for utility and floating solar projects. And in our elite panel, we have Mr. Sergio Plains from L&T, Mr. Varun Sachar from Asan Tracker Private Limited, Mr. Manish Singhal from Aqua Power, Mr. Mohammad Osama from Taka Arabia. The discussion will be led by Mr. Kareem Meghabi from EPDA. Over to you, Kareem, sir.
Thank you very much. Thank you very much, Anand, for the kind introduction and for the invitation also to be able to moderate in the session. Very happy to be with all of you. If that's fine, well, I will introduce myself quickly, and then I will just call you in the order I see on my screen, and then just to make a short introduction of yourself and of your company and what you're doing, and then after we'll go to the questions about the topic today, which is about engineering design and structure and tracker technology. Good morning, afternoon, evening, everyone. So my name is Karim Megabi. I'm the founder of a company called EPDA, based in Dubai, and it's an project origination platform in renewable energy, especially solar and wind. So project origination means that we are working on the early stage of the a transaction. So we try to source transactions for investors. So transactions are mostly large scale, in general above 50 megawatts of solar, either solar and wind. And it could be either in development, or it could be also greenfield in development, in construction, or in operation. And we specialize mostly in Asia, Central Asia, a bit Southeast Asia, and a bit of Africa and a bit of Europe. And this year we have closed 207 megawatts in 4 different countries, and hopefully next year we'll do more. So that's it for my introduction. So now Varun, so you're the first one on my screen, but you already, now everybody knows you, but just a short introduction, please.
Yeah, well, I'll try to be very short on this. Well, I'm Varun Sache, Managing Director for ASEN Trackers Private Limited, and I have my other companies all by the name of ASEN, that is ASEN Solar Power, ASEN Home. We do a lot of EPC installation on the rooftop, primarily focusing into the Indian market. And so this ASEN Tracker is basically a technology company where we have developed this technology after learning a lot of shortcomings after installing a single axis tracker at my plant. And I just want to inform one more thing about this is that we have been granted the patent for this technology by the US, and we are waiting for the patent for 30 more countries to come. Hopefully in next 6 to 12 months, we'll have that patent. So that's a small and brief introduction.
Okay, great. Thank you very much, Varun. Sergio, you're next.
Thank you, Karim, and good afternoon, everyone. My name is Sergio Casanova. I'm the head of business development for Africa, Middle East, and countries, Larsen & Toubro, LNT. I'm in this solar industry market from the last 16 years. I was working in Europe, Latin America, Africa, and Middle East. And as LNT, we are an EPC contractor, one of the reference in Middle East. Especially, we are targeting utility scale solar projects. And yeah, I hope to have the time to discuss on the topic of the mounting and tracker during this session with all of you. Thank you very much.
Thank you very much, Sergio. So Mohamed from Dhaka, tell us about yourself a bit and about your company, what you're doing.
Sure. Nice to meet you all. I am Mohammed Usama. I'm project director in Taqa Arabiya for solar energy. Taqa is number one private sector in the energy business as a developer and energy provider in Egypt. We have more than 1 million customers. We have the complete process in-house for investment, installation, construction, and operation for our own facilities. We work on different kinds of power stations, conventional and renewable. We have our own distribution company. We have Taqa Gas for gas generation and distribution. We have fuel stations. We work mainly in MENA region, and we already started in 2020 to also start in Africa. We have our own branch now in Ghana, Tanzania, Mozambique, and in Sudan. And we are looking for utility opportunities in all the regions we are working on. Thank you.
Thank you, Mohamed. In Egypt, you have ground-based also plants, or you only have distribution?
We have also generation, solar generation, and diesel generation in Egypt.
But in solar, you do have like on the ground, right? Or only?
Yes.
Okay.
Both.
Okay. Cool. Manish, you're the last one. So hi, Manish. So if you can introduce yourself and tell us more about Aqua.
Thank you. Thank you, Karim. Very good afternoon, my friends on the stage, all the participants. I am Manish Singhal. I represent a company called Aqua Power in my capacity as the global head of their solar PV portfolio. Aqua Power is one of the largest private developer, investor, and operator of power, water, and very soon green hydrogen assets. As a proud Saudi national champion, we are playing a central role in the energy transition strategy of the kingdom under the Vision 2030. carrying Saudi flags across 13 countries with a portfolio of more than 40 gigawatt of energy assets, totaling to more than $60 billion of asset value, both the plant which have been constructed, under development, and under advanced development.
Thank you very much. Yeah, I think between Taka and Aqua, I'm French. I think you have the equivalent of the total installed capacity of France in energy. So we are
Yes.
the big players here. Okay, so let's start. Sergio, you're an EPC company.
Karim, I'm unable to hear you. I'm unable to hear you. Yeah. I don't know if it's
can you hear me?
connection issue on my side or
We
your side.
can hear you. I can hear you, Karim.
It's on your side then. Yeah, so Manish, I don't know, try to see your connection. Okay, so Sergio, so you're an EPC company, so obviously tracking systems, engineering design are key. So I'll tell you the context of my understanding of this, the role actually of especially trackers. So we are getting modules cheaper and cheaper, but at the same time, we do have issues on raw material, and we have efficiencies which are growing. And so at a point in time, we believe that LCOE is based as much as the solar panels as the system, the overall system. And so everything which is balance of plant and everything, and tracking system, etc., actually are playing more and more a big role in terms of LCOE. So, but at the same time, I understand also that the shortage of raw material recently, the prices have decreased somehow because it's aluminum and iron and so on. So, can you tell us a bit more about how you see the evolution actually of these systems? What's the key elements for you to improve the LCOE somehow in your design, and how what's the role of this structure and tracking systems?
Okay, thank you for the question. I think the tracker or module mounting structure, it's one of the key elements of the solar plant, because this is what, as you said, solar panels has to be there for 25 years, and the structure that has to hold this expensive component that is the module is the structures at the end. At the beginning, people was concerned, I'm speaking at the beginning of the solar industry, was concerned on the maintenance of the tracker technology, how that durability. And most of the projects was start building on fixed structure. But during the time, the technology of the tracker system was improved a lot, especially in utility scale system, start biggest productions to be competitive, dropping prices, and technologies that could generate higher generation. And this is what today tracker depends on the region, that is true. But in the regions that, for example, Middle East, that radiation is high, for me, at least, understand that tracker system has very good point or to be installed. This is my understanding. And on the pricings, yeah, for sure that tracker has to be adjusted frequently. How is the technology of the modules improving? And how has to be the technology, what we need to do on the tracker system to improve this generation. Because at the end, what we are looking for from the developer, EPC contractor, is to stay, to install a solar farm that will be there from long terms and with huge generation, achieving the best LCOE possible. Thank you. Karim, you are in mute.
Yes, this time, yes, I was in mute. So thank you very much, Sergio. Mohammed, you are operating solar plants in Egypt. So if I remember correctly, all the projects in Benham, they are with trackers, right? So I mean,
Yes, single access
yeah,
tracker. Yeah.
voilà. And so how does it work? I mean, is it working well? Do you have issues with that? Do you have trackers which are, because I guess you have a difficult environment also a bit in the middle of the desert. So, what are the specifications that you had to, request? And is there any problem on the O&M?
First, we have to give a brief about Bimban. Bimban is around 1,500 megawatt, okay? And it is not all owned by one developer. It is owned by around 20 different developers. So there is different kind of trackers and different kind of technologies there. Briefly, to be to the point, yani, we some trackers face very minor issues. Desert was not a real problem to the tracker system. Other trackers in the beginning, in the first year, they faced some issues related to the mounting itself and the weather there. But finally, after only around 1 year, all the problems has been solved, and nowadays we don't face any issues with the trackers, and it's very very minor, nothing to be an issue for such a huge project.
And have you made the comparison between, do you know I mean, have you been able to evaluate the gain in production and yield of the trackers?
Sure. The tracker give we may make ours, of course, simulations, but we can say that the trackers give around 15 to 20% more energy yield than the fixed system.
While the additional cost on the
Not
EPC
not
is
not
with
more than
material.
10% more.
Mm.
Not more than 10%. In huge, and what we found that in big projects like 50 megas, 30 megas, and this kind of projects, it's always better to go for a tracker. But in small scale projects like 1 mega or 2 mega or maybe up to 10 megas, it is not feasible to go for a tracker because also the maintenance cost is higher than the normal one, and also the trackers consume more land than the fixed one. As the trackers, if you are using a tracker, you have to leave a big distance between each table and the following one, sometimes 8 meters. But if you are using a fixed, you can go for only 3 to 4 meters difference between each table and another. So also it is a combination between the capacity you are willing to do. If you have a limited land, it is a combination between the capacity of the land and the returns and the EPC price and all of this together to take a decision. So more likely, if it's below 10 megas, we don't go for a tracker. It's always better to go for a fixed one.
Okay, thanks. Manish, I mean, you have plants in many different countries and with very different climates. And so I'm wondering how you approach the tracker. Actually, last time, I was with some friends from, another IPP, and we were talking about India. And naturally, I mentioned, but you have trackers. But they look at me and say, Karim, you're way, behind now. It's there's no tracker now. So I was very surprised. So in your case, in Aqua, how do you look at the trackers? I mean, how do you see, in terms of countries, adequacy, and role of trackers?
For us, the decision making is very simple, Kareem. We are absolutely agnostic. It depends upon case to case basis. For every bid that we do, we run multiple scenarios, multiple technology combinations. Like Osama mentioned, there are various factors that goes into decision making, the availability of land. The end goal remains with which technology we get the lowest cost of energy. So far, for all the plants that we have done, except 2 plants which are on fixed tilt technology, all other plants have been built on tracker, naturally because the LCOE was far better. So in terms of our experience, it's absolutely agnostic. Trackers are gaining momentum because of the changing competitive landscape. There is more fierce competition and everyone is trying to move towards the lowest LCOE point. And trackers, they come to the rescue because of the value advantage that they provide to the developers. There are a lot of innovations happening globally. There are various players in the tracker industry who are, besides the product that they sell, they are adding value on the software and on the AI part of it, which is on the last few months and 1 year is adding significant value. So from our perspective as EcoPower, we take decision on a case-to-case basis. Having said, in today's scenario, when we are seeing module prices being approximately 40 to 50% higher than what they were around 8 months back, the attractiveness of tracker is even higher because it's inversely proportional, directly proportional. If the module prices are very high, quite possible that those who have been using fixed tilt earlier, they might now be encouraged to adopt the tracker technology. And Varun, thanks for your nice presentation. While so far people have been shying away from dual axis tracker, I guess now with more and more competitive pressure coming in, you will see developers to be more open towards the dual axis tracker idea as well. All the best to you.
And can you tell us more about the innovation? So, I mean, there are two types, I would say. One is the equipment itself, right? So I guess the small motors to move and how they move, or even the material used, etc. I mean, one maybe, I don't know if you can tell us more. And then, as you mentioned, the way it operates actually with the software and I. Can you tell us more actually about how what kind of evolutions you see and what's the impact in terms of either O&M or cost or yield?
The yield depends upon various factors, Karim. It depends upon the GHI levels, the latitude at which you are setting up the project. So it varies from one location to another. We have observed that it ranges from as high as 20%, 21% to as low as 13 or 14% also. In terms of the value addition from the software, majority of the tracker suppliers now coming up with various algorithms whereby each tracker backtracking mechanism is different. Previously, all the tracker used to backtrack all at the same time, but nowadays there are specialized algorithms where we are able to extract higher value in the early morning and the late hours when we see a higher level of shadow, and that's where when you have differential backtracking strategy, you can extract some extra value out of the tracking system.
And do you see any change because of, for example, the shortage of raw material and maybe the increase, of the cost actually of the tracker itself? Are we trying to reduce the material they used, or is there any kind of movement in this way?
No, if you track the historical price curve, we are seeing prices of the tracker going down, bearing the recent spike in the steel prices and the zinc prices, which has created temporary hiccups. But on a mid to long term basis, we believe that the technological innovations happening in the tracker design, the higher efficiencies of the module panel, and more trackers adopting universal design concept wherein it is suitable for any kind of solar module. We strongly believe that the prices of the tracker will continue to be going down in the near to midterm future.
Very interesting. So, Varun, in this space, of the different, the players which have been, around for quite some time, tell us more actually about, how you position your technology and, what, where you see yourself actually in the future.
Okay.
We,
See, solar tracking technology has been existing past many years. In Europe and in US, people have been using on this technology. I also use this technology on my solar plant, and when I observed the performance of the existing single axis tracking technology, I felt that there is something missing in it. And that missing part came to me, when I observed that the sun path is different during the winters or during the equinox period when it is moving from north to south. So that was the position which the sun path need to be addressed, which was unaddressed by the single axis tracker, whereas dual axis tracker does do that. And I am what I'm trying to position myself is, see, I have applied for the patent for many countries. What I'm trying to position myself is to the market where I find has got tremendous scope. Where people are adopting to the latest technologies. They want the levelized cost of energy to be reduced quickly. They want the returns to be done much faster way, you know. So and the payback period to be reduced. So that is what I'm trying to target at, and that's what I'm trying to target.
Well, apparently you already have Manish who says that it's interesting to do a tracker, so maybe you already have one company interested. But tell us more.
Unfortunately, I'm not able to hear Mr. Manish what he said.
Ah, really?
Because there's something wrong with the
Well,
speaker.
he said that.
No,
he believes
Varun,
No, there's something wrong with the speaker.
no, there's something wrong with on my side, Varun. Are you able to hear me now?
What exactly? But yeah, I do not know what he said. But
Can you
yes.
Can you hear him now? No, we can hear him actually.
You
Can you
hear
hear me
him, but
now?
I can't hear him and Mr. Mohammed. Two gentlemen I can't hear.
Really? But he's speaking now.
Oh,
I can hear you quite well. I can see Anand and Mr.
How come
Sergio.
you can? that is something very strange. This one. Okay, I'm sorry.
Kareem,
Okay.
I guess you are our medium then.
Yeah, then
Maybe I was telling to Mr. Varun.
yeah,
I was
exactly.
telling Mr. Varun that he is at the right point. That
Did I
this
say something?
technology.
What was I
Wait, Mr. Varun. I will tell you what Manish is saying. Yes, Manish, please.
Please.
So I'm saying that Mr. Varun has introduced his technology at a very opportune time, where the developers like us and others in the market, they are looking for more and more value, and this is the right time for him to start aggressively marketing his product. And I hope that he will have enough credentials and balance sheet to kickstart at a smaller level, and then we can grow.
Yeah, so Mr. Varun, so Manish said that actually he believes that you are coming at the right time because now markets are more and more competitive, and developers they are very much aggressive actually in their offers. So they are trying to lower as much as possible the SAOE, and they're trying to look at different technologies. And so you're coming at the right time. And what he is hoping is that you will actually have enough credentials and balance sheet also to offer your product to other companies. And that one I can comment actually, coming from the banking sector. Well, it was 15 years ago, but still, you're always a banker, it seems so. So I can tell you that indeed you need to design a strategy whereby first of all, lenders, they look at the number of megawatt installed, so in the tenders now what they say is that minimum 100, 200, so you cannot start like that, obviously. Yeah. But you need to build up rapidly these references, and also the balance sheet for the guarantees also it's becoming more and more important because all these players, Taka, Aqua, and EPC contractors actually, etc., they want to have their suppliers to have to provide guarantees now, and therefore that's something that you need to structure for sure, either by yourself or partnering with large players. Also, that's another possibility. Many also players they do this they play this game actually trying to partner with big industrials also.
Yeah, thank you for translating, Mr. Kareem.
Right, she said, "Thank you for translating." That's never happened. This one. Okay.
But I'm able to hear
Answer to
him,
your first,
Karim.
I
I'm
would
able
like
to
to
hear him
add
very
something.
well.
Sorry, I would like to add something to your first question. Trackers have today become very viable product. Earlier, if you just look at it, 6 months, I mean to say 2 years down the line, people were not talking about trackers. But now people have started talking about trackers because the watt per panel has increased. The cost of the MMS has gone down. So gradually, the cost for the trackers have also gone down, because you require less number of trackers for less number of modules per megawatt. So the, that's the game today, which is happening today in the market. And bifacial is one technology which is like by default our design is very compatible to bifacial machines.
Okay, thank
So,
you. So Sergio, tell us more. You see, you saw actually the discussions with Aqua, and obviously this could be one of your clients, right? And so how do you approach that? Well, first of all, do you see many dual trackers in the market, or is it still very new?
Second question, could you repeat, please?
The dual tracking system, actually, do you see them a lot in the market or not yet?
On this Middle East region and utility scale, I cannot see. What we have, it's single axis tracker, mainly in all the utility scale, 1P, 2P, but all tracker is across the utility scale solar projects here in the Middle East. And how we approach, I think that we already put all these points on the table, but mainly it's as a PC contractor, we are supporting our client with the best that we can, doing all kind of different configurations to reach the best LCOE analysis. And the trackers that is being selected, firstly, has been passed a process internally as a EPC, but also from the developer point of view. Our client has listed what should be trackers that are bankable for this project opportunity, tender, whatever is there. And based on this list, this is what we are trying to do, the different configuration, depending on the typology of the project. Sometimes one tracker fit better than other. Land available, all these things are impact. This is one, but to be in this vendor list, let's say that, it's important for sure bankability of the company, big balance sheet of the company, but also of the product. How many megawatts has been installed on this tracker? This is also important for this because we are speaking here and projects like 1 giga, 300 megas, it's a big project. And from the point of view of the lenders, of the client, product has to be bankable, has to be tested, has to be used in a huge amount of projects. And this is something like has to be considered. This is another point. Also capacity, manufacture, how many megawatt, gigawatt has the capacity to produce yearly, because sometimes or all the times to execute the projects are very short. We're speaking about 1 year, 2 years, 3 years, depends on the big of the projects. But sometimes also for one only manufacturer, it's quite tough. If we are speaking huge projects in solar, this is something like also capacity has to be evaluated, and for sure, lead time, how long will it take from the purchase order to deliver it on site. All these things and test has to be certified under who certified the product. All this warranty, for sure, warranty is something like has to be considered to understand what's warranty, what is required from the specification from client, from the tender, from the lenders. And all these things are the ones that impact on the moment to choose the right tracker, mainly. And finally, I think that I don't need to mention price for sure. Point that will impact finally on the tariff and the scenario. That I think that we don't need to mention that one. This is understood.
Actually, you raised very good points. Maybe two questions. One is, so does it happen that you have different tracking systems on one plant? If it's too big, and I don't know, they are constrained on the market, then you have to request from different suppliers. So do you have different tracking systems?
Usually, you used to find just one manufacturer for the projects, but if we are speaking here that I don't know 1 giga or more than 1 gigas, that also some projects has been developing. Maybe it could be a good point to understand, because to have a 1 giga project, it's a lot. Yeah, maybe it's time to evaluate because happens something to one manufacturer and you cannot stop the construction. Maybe you need to have a backup. For this big utility scale project, it could be considered to have 2 or 3 players at the same time.
Interesting. Mohammed, actually, is it what you see? I mean, I don't know how many megawatt actually you have in Benban, but and as you said, it's split right into different IPPs, different
developers.
Yes. So I remember a long time ago, modules. I remember visiting plants where you had this line with this module manufacturer, this line with another manufacturer. So do you see that, for example, in tracking systems, or do you have one single manufacturer?
Normally, if we are speaking, as Sergio was saying, if you are speaking about the normal scale, like 20 megas or 50 megas, or even 100, you will go for a single company to do the tracking system. But what we found in Bimban, because Bimban is 1,500 megawatts, it is 1.5 giga. So of course we have there around 4 or 5 different tracking systems, not only one, of course. This is normal. Also, from the perspective that we are speaking about, if we take the idea of that there's one developer doing around 1 giga, of course he may go for 2 different tracking suppliers to make sure that if something happened with one of the factories, that the project will not be postponed. I think this is a very good idea to eliminate this risk, because sometimes this risk happens even with the panels. If something happened with the manufacturer, you face a delay in the whole project, and this is of course not good financially for any developer.
And what are the differences between the different tracking systems? Is it about motors? Is it about software?
Everything.
Can you tell us more, actually?
Everything. Some of the trackers have only one panel at a row beside each other, and other trackers have 2 above each other. Okay. Some of them have a motor that works with an AC voltage, so it is connected to the grid or the network to take electricity. Others use DC motors that get their electricity directly from the modules. They have no AC connection. Some of them are very huge, bigger than the others, so they need bigger distance. There's a lot of differences between the tracking system. A lot of differences.
Manish, I think you're the only one here with one single plant of gigawatt scale. So tell us, we were just wondering how you were managing your tracking system. So how many manufacturers for one plant?
So we generally prefer to have single manufacturer, but now these days the size of the plant have really gone extremely big. We are currently building one of the largest plant in the Kingdom of Saudi Arabia with a capacity of 1.8 gigawatt, where we believe that more than one tracker is expected to be used. But coming back to what are the criteria for selection of a tracker, I guess there are many. The biggest criteria is is the stability of the design under environmental condition. The most important is the wind speed for which they are designed and whether it has passed from a third party consultant, the design consultant. That's extremely important step. Second is majority of these trackers are being used in a sandy and dusty areas, whereby their ability to withstand the corrosion and abrasion both is extremely important. So a lot of our effort goes into the design due diligence, where the potential supplier, how strong is his design team, how much third party design validation they have already obtained. We have our own design team and a separate owner's engineer who do multiple level of due diligence on the design. Last but not the least, it's the performance. Overall, how much energy yield the tracker is able to give to you, and what are the software and the artificial intelligence competency that the tracker has in them. So various parameters, but the most important is the stability under high wind condition and how the tracker is expected to perform. And of late, we have observed another very critical component, which is the ability of the trackers to integrate with robotic system. Most of the plants in Middle East and elsewhere in the world, they are now expected to go with fully automatic robotic cleaning system. And when tracker has to work with robots, it's a lot more complex interface that needs to be carefully managed, both from the software aspect as well as from the hardware and the structural design. The moment there is lack of coordination between the two, you will get stuck. Because robotic is a nascent field and usually you have two different suppliers, so interface management becomes extremely challenging task.
Oh, this is a very good point. But Varun, you can't hear anything, right? Of your, because you should take note on everything on this one. Varun, yeah.
I'll tell this first energy to talk to me, you know. Send me a
You will
recording.
have to look to see the replay,
Yes,
because now we're talking about robotics and actually cleaning the solar panels, which are obviously an issue with solar trackers. I mean, not an issue, but you know, it's a challenge. So I guess with dual trackers, it's becoming even a more challenging issue. What's your view here on the cleaning system?
Yeah, we have already done a few pilot projects, and we are using robotic cleaning system on that.
Oh.
So there's a solution to every innovation. So we have got the solution to this.
Mohammed, in your Bemban, you have robotics also. I mean, this is because you see, Manish said that basically more and more we go for automatic cleaning systems, and obviously if we go also for tracking systems, then I guess it should be well aligned. If not, your robots start to go anywhere. So how do you manage that?
In Bimban, not yet. Bimban is still using some developers using manual cleaning, and others are using cleaning machines. So right now in Bimban, it is mainly most of the developers are using cleaning machines, okay, but not robotics. I believe Manish was speaking about. I think in the near future, this will be the case because the mix between the tracker and the robot, this needs to be worked on to be able to use automatic robotic cleaning system when you are having a tracker. This would be, of course, perfect, but until now, this is not yet feasible. And we studied the idea, but still, its figures are not. It is not comparable with a normal cleaning system. The normal cleaning system is much cheaper than using the robotic systems.
Sergio, this is what you see also in your design of your EPC?
I'm on Manish's side, means at least in this Middle East, on this utility scale, we're speaking more than 1 mega, 2 megas, 3 megas, in above. Module cleaning system, it start to make sense. And this is something like also we are trying to implement on our projects.
And how do you manage this, cleaning system, robotics plus tracking system? How do you manage that?
Yeah, you need to choose a module cleaning system that fits the tracker that you are assembling. This is what, and also all the tests has been done just to understand that this robotic module cleaning system or the structure, the tracker support the weight, how many times is going to be passed this robot cleaning. All this calculation has been done just to optimize also this O&M site. But yeah, on this region, start to doing. Also, we are speaking here in a region that is desert, and dust is there, and an important cleaning plan has to be done if the generation has to perform the plant as was as per the design. And this is what became one of the relevant points on the maintenance, on the performance of the plant. The module cleaning system has been implemented finally here in the region.
Mohamed, that's what you see also in Benban, the cleaning system, how important it is actually, how often you have to clean, and how long it takes also to clean actually your full plant.
We use two cleaning machines. It's like a car with a big brush that cleans the site. Okay, we do 2 cycles per month. Yani, we can say that, of course, I'm speaking about 50 megawatt facility.
Yes,
With 2 machines, we do
63 megawatt peak, right? It's 63. It is the
60 some, yes.
Yeah, it's
Yes.
50 megawatt AC, right? This is the
Yes. It is 65 DC and 50 megawatt AC. Okay. So we have around, of course, it is basically about the number of modules. So at that time, the 330 and the 320 watt was the modules we used in Pimpan. Okay, so we have around 200,000 modules on site for the 65 megawatt peak. Okay, we have 2 cleaning machines, and we have 2 cycles per month. So almost we every 15 to 20 days we have a complete cleanup for the facility. We studied, of course, the idea of the robot, and we found that we will need a lot of robots to reach the same level of cleaning. And of course, the cleaning machine was very much cheaper than using the robots. Even, and this is not only Taqa, all the developers in Biban, they don't have robots because of that. And even Aqua, they have around, I think, 75 megawatt in Biban as well. Yeah. And all are using cleaning machines.
Manish, how do you see that then? The robots are for the future then, or how do you see when robot actually would make sense compared to the machine? I heard also that actually Ben mostly cleaning machine, right, and robot were not there.
So in Benban, we have approximately 170 megawatt, 3 plants running. All 3 are currently not using robotic, but the latest plant that we have commissioned, 600 megawatt in Oman, which is fully on robotic. We have another 1 gigawatt under construction in UAE, which is again fully on robotic. So all our future projects are planned to be on the robotic design. And the commercial case of robots is not so far not found in Egypt, because you have very cheap labor. The cost of the labor in Egypt are still very cheap, but I'm very sure that if not today, within next 2-year or 3-year time frame, the developers will realize that robotic are making more sense when you have more affordable robotic solution providers available in the market.
I completely agree.
Okay, thank you. Very, very interesting. And so Varun, maybe we can conclude. Maybe I don't know, Anand, how long we have. But so Varun, maybe can you tell us more about your, how to adapt what kind of cleaning system? Actually, it's even a question that we received in the Q&A from the audience. What kind of cleaning system would you use for your tracking system?
See, we use the similar robotic cleaning system, the dry cleaning which is being done without even using sprinklers or water and all. And this robotic cleaning system can function on a tracker when the tracker comes to a stop position. When all the modules which are moving from east to west, they come to a horizontal position, and the table also comes to the horizontal position. So this cleaning is normally done in the evening, and in one row we put a docking station for this, and the same row in the end will have a reverse station. So it's a very novel process, and it moves on a rail which we also draw with that. It depends on the customer, so which can support the guiding wheels for the robotic cleaning system.
Okay, thank you.
Yeah.
So Anand, tell me how long we have if we should conclude for the session.
So we still have like 10-15 minutes. There are many questions in the
Yeah, I
Q&A
see there are many
session.
questions here. Maybe let me ask you maybe one or two questions to the panel, and then maybe we can go to the Q&A. So Sergio, actually, for my knowledge, for my understanding, and now with Varun, I kind of understand better the rails, right? You have for the robotics, you have rails, and the robots they would go. So basically, the cleaning would come, I guess, at the when there is no sun, right? Because you need to have the same position of all the panels, so it's horizontal. How does it work exactly?
I think that today on the market you can find a different kind of robotic cleaning system. They run to the rails of the frame of the module. There are that works on horizontal and also in vertical. And today has been tested, and it's working properly well. This is what you can say. This is what has also Manish said on this big utility scale project. Also on all our designs, this is the first option, at least in this Middle East region, and this is because has been already tested and approved for the external technical advisors to install on this manner.
Okay, and at which time of the day? Is it evening or like not when there is the sun, right? Or it could be during the day as well.
You try to avoid on the sunny days,
obviously. Okay, okay, and Anand, maybe if you can, check the questions from the audience.
Yeah, sure, sir, sure. So I'll just bring the questions on stage. So here the first question. Varun sir, this is actually for you, I believe. Varun sir, you're on mute.
Yeah. You want me to answer this question?
Yes, sir. This question has come from audience.
Yeah. Mr. Ahmed, see, there's a distance between the two modules. So depending on the location, we decide what should be the distance between one module to the other module. In area above the Tropic of Cancer, where I think Egypt also falls under, it is somewhere around 400 mm distance we keep between the two modules. So there is no shadow on any adjoining panel. If in case there is any, there's a backtracking facility available. So from east to west is a backtracking available, as well as from north to south. So both the movements, it has got a backtracking facility. Yeah.
Okay, thank you, sir. So I'll show the other question. This is from Mohammed, sir, I guess.
Yeah.
Yes, but not all the projects require 25% local content in Egypt. Also, there are some factories, mounting factories in Egypt. So sometimes it's really about the project and the financing. Sometimes it is required to be a local content, and sometimes it is brought from outside Egypt. And also, we don't have a tracker manufactured in Egypt. So if the project needs a tracker, it will be imported from outside Egypt, not from the local market.
Thank you, sir. So the next question. So anyone can go ahead and.
Yeah, I can speak about Egypt, of course. Normally, if we
I
are
think this
using
question is to
fixed
me.
tracker, sorry.
Stability has been ensured considerably
No.
model tilt from north to south direction, and what is the maximum range of nozzle? Is this a
Wait,
question?
Mr. Varun, Mohammed actually was answering, so just wait.
Oh,
He's
I'm
answering.
sorry.
Yeah, no,
I can't.
we know the situation.
We understand,
So,
yeah.
yeah, we understand. No worry. So, Mohammed, please, don't worry.
I will give a brief
I
answer, and of
surrender.
course, Varun can continue. Normally, in Egypt, we go for a tilt angle of about 23 degrees. This is the best for us in Egypt, to 25 degrees. This is for Egypt, but of course, worldwide is different. And Varun can give, I think, better answer than me.
Yeah. Varun sir, you can also answer this question now.
I think
Varun,
they must have got
Yes,
the
Mr.
answer.
Varun, now it's you. You can answer also.
No, it's okay. I think they have got the answer.
Okay, so next one then, Anand.
actually, this question is for Varun sir. So
Yeah, we have not done any wind tunnel test, but we have done CFD analysis, which we find it to be more correct and accurate so far as the wind loads are concerned. So we have got the CFD analysis done on this. But if given the option, we can do that also. But we are banking on the CFD reports.
okay, so these were the questions that were in that our attendees asked. So now I'd like to thank all our esteemed panelists for this wonderful session, and a very thanks to Kareem sir for superbly managing the session and also doing a little translation. So thank you so much, sir. It's always a pleasure to have you.
Okay.
So now the show is not over yet. We are taking a short networking break and we'll be back with another exciting session on the topic structural engineering trends and new age mounting technologies for rooftop solar projects. Till then, explore our exhibition launch, network with our peers, and join our sponsors on the networking table. Thank you. We'll see you in. Welcome back, attendees. Hope you had a good time networking. So let's start with our second session for the day. Now I would like to invite Mr. Malik Newman Khalid sir from Yellow Door Energy to give his knowledge presentation. Sir, you can share your screen now.
Hello, hi, good afternoon, everyone. I believe my screen is visible to everyone.
Yes, sir.
All right, thank you very much, Anand. Thank you, everyone, for joining this session. So I am Malik Numan Khalid. I'm the VP Technical Design at Yellow Door Energy. So basically, today what we are discussing here is that we will be looking at the latest solar mounting system technologies. So we will be discussing that what are the factors required or what considerations shall we keep in mind before we are designing a PV system, before we are selecting a solar mounting system technology. So the agenda for today's presentation, my presentation will be around a bit about Yellow Door Energy. Then we will discuss that if the building which we are considering for a PV mounting system, it is a good candidate for rooftop solar or not, making sure the roof is solar ready with the HSE and retrofitting. And then lastly, we'll discuss about the solar tracking systems for the the ground mount systems and for the CNI market for rooftop solar. And then we'll close at the insights and the summary. All right, a bit about Yellow Dot Energy. We founded in 2015. At the moment, we have 120 plus megawatts of commercial and industrial solar projects in UAE, Jordan, Pakistan, Saudi Arabia, Bahrain, and we are expanding further. This is our shareholders. So we are backed up by IFC, Mitsui Corporation, Equinor, and Epicorp. Now, coming back to the agenda of this meeting and to the topic. So the first question that comes to mind is that when you are looking for a PV system on a rooftop solar, the first question is that if the system or if the building is ready to take solar or not. Now, then there are a few aspects whereby we deep dive and see that, okay, all right, what are the aspects which affect the installation of a PV system on a rooftop building? So first one is the building orientation. So building orientation means that at what angle your facility or your building is facing the sun. If you are in the northern hemisphere and if you are in the southern hemisphere, what are the effects of northern hemisphere and southern hemispheres, and what are the factors which we need to keep in mind for these two hemispheres? So there are different sorts of rooftops. There are different configurations: flat rooftop, pitched rooftop. In commercial and industrial scale, we mostly see that there is a metal rooftop, which is a corrugated sheet, which is a trapezoidal sheet, or is a standing seam rooftop, which has multi-orientations. Then for some of the commercial clients, we see there is a flat rooftop, which is constructed out of concrete. So the best practice is that if you have a single pitch rooftop, run the long axis east-west to give large southern exposure applicable in northern hemisphere. So for example, if in UAE, at the moment I'm in UAE, so we are in the northern hemisphere, so we have to face towards the southern hemisphere to get the maximum exposure of the sun. But for example, if we are in Australia, somewhere in Australia, then it will be the other way around. Or if somewhere we are living on the equator, for example, in Kenya, in Africa, so we are almost on the equator. So it will be like, I mean, dependent on your location, you can either face northern hemisphere or towards the southern hemisphere. For a dual pitch rooftop, for example, if we have an east-west orientation, that will be the best if we have multi-orientation rooftop, because then we can track the sun maximum. But for example, if we are not fortunate enough and we are facing north and south, so then the south side will compensate for the north side, but still on the north side, the losses will be much more and the performance will not be that great. Second thing is the roof aging, which is a very important topic for all of us while we are considering a PV system. So for example, if we are doing a retrofit on a let's say 20 years old building, so we need to keep in mind that this is an old rooftop and retrofitting PV system shall not affect the integrity of the rooftop. So we need to find out ways how we can mitigate those risks, and we need to select a PV system and the mounting system accordingly. So for example, we can, if it's a standing seam rooftop, we can use a standing seam clamp, whereby we will avoid the penetrations into the rooftop. So we'll avoid any damage to the integrity of the rooftop, we'll avoid any leakages, and the integrity of the building will be very, very secure. Ensure the materials are anti-corrosive. We are using, proper materials. If there are different metals in contact, we are avoiding the galvanic corrosion between different metals. We are choosing the mounting system accordingly. The choice of EPDM, the choice of PV modules frame, the choice of structure. So it shall all be aligned so that we don't damage the integrity of the rooftop. There are different sorts of rooftops: flat rooftops, slope rooftops. Commercial and industrial scale, mostly will look towards the metal rooftop, which are the pitched rooftops. Flat rooftops, I think it's an excellent candidate for a PV system, whereby there is a straightaway case, and the structural bearing capacity of the rooftops is also very, very, very good. So the only thing we need to factor is that, okay, which orientation do we look for? What tilt do we look for? What is the capacity required to install? And then at the end of the day, what materials we are choosing for the erection of the PV system. Slope rooftops, the best candidate is the standing seam rooftop, whereby we avoid any penetrations into the rooftop, and just with the friction of the clamp, we can stick the mounting system with the existing rooftop. The standing seam rooftop itself must be attached to the structure well enough. So we need to make sure that there is a structural analysis performed on this thing. Yes, we know that there is no penetration, we can install it. But then again, we need to look at the structure which is holding that standing seam together. The structural integrity. So this is, I think, the first step whereby on any building where we are looking to put solar. So we need to confirm that the structural integrity of the building is intact. It can withstand the dead loads, the lateral loads, the snow loads, the wind loads, etc. the roof must be capable of carrying the load of the solar equipment. So what a general practice is that a third party or an independent consultant is hired. So this consultant is not the EPC contractor of the PV plant. So it's an independent body which vets the structural integrity of the rooftop, checking, whether it's a metal rooftop, it's a concrete rooftop. So there are different analyses performed on the building. And then there are municipality approvals so that the structural integrity is first made sure, and then there are no consequences for tomorrow that this PV plant will fail. Summary for the roof guidelines, these are very generic guidelines. So this will be applicable to most of the sites, depending on the site condition. So for example, we say that the rooftop equipment shall be minimized. Minimized as in that, for example, if there is a possible place whereby we can put inverters, we are not loading the rooftop. If it's a metal rooftop, the type of roof installed can greatly affect the cost of installing solar later. For example, if it's a new construction, then these points shall be kept in mind that if we are looking for a standing seam rooftop, we are looking for a corrugated sheet, we are looking for a trapezoidal sheet, or we are putting a flat rooftop system, right? And what orientation shall we follow? So all these points will help us for tomorrow, that if we are putting a solar system, it will be very beneficial in the energy generation part. And then, as we discussed, that the structural integrity shall be made sure. Then there is a very important point here that most of the industrial rooftops, they have skylights. And then I'll discuss later in my presentation the HSE factors which we need to keep in mind before digging into any PV system. Okay. Certifications which are usually and generally followed for the PV mounting systems. So these certifications are relevant to the fixed tilt mounting systems. Fixed tilt mounting system, as in, like, I mean, we are talking about the complete system, not just the rails or not just the fixing clamps. So it talks about the complete mounting system, whereby it includes the rails, the short rails, the EPDMs, the clamps, the nuts, the bolts, etc. So these are usually 1703 UL, UL 2703, UL 3703 for the trackers, and IEC 62817 for the design qualifications of the solar trackers. And then there are different, tests performed. These are lab tests, these are site tests for the fixed tilt tracking systems and for the tracking systems. So usually the most popular are and the most needed are the wind tunnel testing, mechanical load testing, tensile strength and compression. And then lastly, we have salt mist and corrosive atmosphere testing. Now, this is I mean, it was not the taste of today's meeting, but we wanted to, as Yarudo Energy, we wanted to, highlight this very important aspect, and we want to make sure that, okay, each and every installation in the solar fraternity, it's making use of these HSE standards. And then if we are retrofitting any PV system into an existing building, it should check all the boxes so that the PV system is safe and ready for tomorrow. So the focus is on health and safety. What are the benefits for health and safety? We shall minimize incidents on site. So whether it be a fatal loss, or it's a life loss, or it's an injury. So we want to minimize any sort of bad incidents on the site, reduce system downtime and increase operational efficiency. And then lastly, foster a culture of health and safety for the solar industry. Now, what are these safety parameters on the site? I'll discuss further in detail with a case study I have for today's presentation. So mostly, what is safety and access? So safety involves lots of things. For example, if you are working on height, or if any system is operational and it is installed on a rooftop system, it is at height. So the height is itself a risk which we need to mitigate in all the installations. So what are the mitigations here? So the mitigation for the rooftop is, rather than walking on the rooftop, rather than walking on a metal rooftop, it's not safe for you, first of all. Second thing, it's not safe for the building, it's not safe for the rooftop, so you need to put the walkways. And then you need to foster a culture for all the employees, for all the laborers, for all the technicians, engineers, project managers, and anyone who's a visitor on the site. They shall also always be visiting with the proper PPE equipment. They shall be wearing the harnesses. They shall be, properly latching to the safety lines with the lanyards, and then we have a proper access to the site which is covered, and then the skylights are also covered so that there is no risk of fall and there is no risk of anything on the site. And then lastly, if there's a good access in case of any emergencies, in case of any problems with a PV plant, or if there is any, let's say, health HSE risk, so with a proper access to the site, this can be mitigated. This is a case study which I presented to you today. This is a project which Jet Door Energy did for Future Pipe Industries. It's a 2 megawatt peak project scattered over 4 rooftops. It's an industrial environment. The climatic conditions in UAE, we all know that these are very harsh conditions. And then for all of these 4 rooftops, we didn't have any HSE equipment on the rooftop. So the challenges were there are skylights on the rooftop, there are mechanical vents on the rooftop, there are no parapet walls. And then at the end of the day, we need to install a capacity whereby we can satisfy the client needs as well. So in order to mitigate all this and to put this into equation, we wanted a mounting structure which can accommodate for a 2 megawatt peak system solar capacity, which can accommodate for all the HSE as we discussed in the last slides. For example, the walkways, the safety lines, the skylight covers, and then the proper access as well. So with a proper design, which was made on paper beforehand, we were able to install and deliver this project with the required quantities. Now, lastly, about this solar tracking system. I'll just show you a time-lapse video of a solar panel trackers, which we did at Wadi Al Lash. It's a 4 megawatt peak plant by Yellow Energy. So as you can see, this was a 24 hours time lapse. So these trackers are installed north-south axis, and then they are tracking the sun from east to west. So which way you can flatten the PV curve and you can generate what was missing with the fixed tracking system. So with the help of tracking systems, what we can do is we can generate more electricity. And then there are two most popular sort of tracking system. So first one is the single axis tracker, whereby you can either track tilt or the orientation angle. Dual axis tracker, you can track both the tilt and the orientation. The benefits are due to increased direct exposure of PV modules to the sun, we can generate more electricity. For example, there are certain utilities which have the function of time of use. So if you have that facility available in a particular country, so this can help maximize the energy generation during peak hours. And then for sure, with a lesser number of PV modules, we can generate more with the tracking system. Okay, now what are the challenges with rooftop solar tracking systems? So rooftop tracking solar systems, there are a few examples around the globe, but still it's not to scale as of now. So what are the challenges are the first challenge is the building type. So the current technologies are not compatible with, are mostly compatible with flat concrete rooftop types. So for example, in commercial and industrial scale, we have mostly pitched rooftops. These are metal rooftops, so the trackers won't be applicable there. And then there are climatic conditions. So for example, rooftop is at a certain height. So when there is a height, there is always a risk of high winds. And then you need to make sure that the weight of the trackers can be withstand by the rooftop. So this can be mitigated with the low center of gravity design. So as we see in the market now, there are some designs which can mitigate these risks. And then lastly, whether it is for a ground mount or whether it's for a rooftop, the capex and opex for the tracking systems are generally high than the fixed tilt systems, because it has moving parts. It requires more maintenance. So what we can imply from this is that not every rooftop is suitable for tracking systems. Individual module trackers can present a strong case on commercial and industrial rooftops. The design and O&M constraints are still persistent. Careful site considerations and engineering can mitigate these risks. Lastly, what are the insights and summary when designing a building? So if you are designing a building, if it's a new building, please make sure that whatever we discussed today, it is kept in mind while designing the PV, while designing the building. So it will help us tomorrow. If there is an existing building which is not designed for PV systems, still it can be retrofitted with a proper design, keeping in mind all the design considerations and the HSE considerations in mind. Solar tracking systems are not yet techno-commercially matured for rooftops and CNI sector. As said before, yes, there are rooftops with tracking systems, but still it is not a very much proven and mainstream technology for the rooftops. And then lastly, speak to a trusted solar developer to assess your building solar potential. Thank you very much.
Thank you, sir, for this insightful and knowledgeable presentation. Now, I request my team to please play the sponsor video of Stroller. Thank you. So now moving ahead with our sponsor presentation by Mr. Harshal Akhori from Stroller. Harshal, sir, you can share your screen now.
Yes. Is my screen visible?
Yes, sir.
I would like to keep it really short and sweet. A brief about Stroller and what we're doing here. And I would conclude the presentation like this. So Stroller has been in the market for around approximately 7 years now. And we started with a design-based company, later propagated towards manufacturing. We have been India's choice of mounting system when it comes to rooftop, which is why we were the first company to cross a gigawatt in rooftop supplies here in India. So just a brief about whatever is I'm going to talk about. It's we've been in around 6 7 years, as I said. We've been we have manufacturing units in Greater Noida and in Kosi Kalan. Both locations are, one is your aluminum manufacturing unit and the other one for your steel units. Stroller has been in around for a sufficient amount of time to design and pioneer many firsts in the industry. So we designed, the first ever carport for a major metro, company here in India. We have, designed systems on tracks, right? This is something of a first, I think, probably done ever executed, right? Stroller is also backed by a decade experienced technical team. We have, around 11 patents that are pending in design, right? And giving to clients' requirements, we have been, at the forefront of understanding what the needs is at the ground, and we modify our products accordingly in order to meet the changing demands. Uh, the three co-founders in the company are myself, Gaurav, who looks after the operations, and Rajendran, who looks after the technical side of things here in the company. We have recently been active in the international market. We have, we have been serving India market for quite a while now, and we've done around 7,000 odd projects overall. These are small milestones that we've covered. When we started in 2015, we invested heavily in R&D. This is when the first company in India, Indian company actually, to do wind tunnel testing on the mounting system. We were them, and this is how we progressed. That system was implemented on a utility scale rooftop, and we were also one of the pioneers in executing utility scale rooftop, not one but multiples. When around in 2015 we did our first international shipment, which was in Bahrain, and at that point in time we had crossed around 7,760 megawatts in supplies. Stoller is a brand name for effective and technical mounting system here in India, and we have been looking forward to working everywhere else and providing our expertise of mature solar economy of India. We have certain standard products which we have dedicated production lines. There are different production lines for customized requirement, whether it is large scale or small scale as well. Solar has probably the largest product base here in India. We have 38 plus different with us for your rooftop, ground mount, everything. So basically, we do systems for your pitched roofs, which are seam roofs, your any kind of roof for that matter. And we are also doing your flat roofs, which are RCC based, whether it is east, west, south based, anything for that matter, ground mounts and carports. Carports, we are India's, again, premier mounting systems company when it comes to carport. We have executed one of the largest carports here in India, which is a 20 megawatt carport for MSIL. And we are in process of executing another 11 megawatt carport here in India. So this has been possible because we have a certain knack of innovating. Every single time we see a certain problem or an upgradation in the market, we read our design, we work on things, and that's how we get it done. These are quality and certifications, which I think is basic for every single company. So we've done quite a few global projects, and we have been in and around for African market, and we are recently starting up with the Middle Eastern. We'll be loving to serve you guys for your structure requirements. Global projects, as of now, we have served 9 plus countries. These are a total of 28 different projects that we've done. Total cumulative price that we've done given is somewhere around 2 gigawatts, and a totaling of up to 7,000 different projects. So all of these, companies in mounting systems would say that they have these optimized racking, global reach, local presence, quality, manufacturing, and everything. The thing that differentiates from the other companies is, if you're a regular customer with us, we give you pre-bid design support. So let's say you're bidding for a project that's a customized project, and you don't have an approximation of how you would want to go ahead with. Right. This is when we come into picture. We help you with the designs. We help you with appropriated pricing, because everything else is fixed. And for your structures, when you have better costing, you understand your profit margins better, right? And that enables you practically to code better. That's all from my. Thank you.
Thank you, sir. Thank you for this wonderful presentation and setting the tone for our next panel discussion. So let's start with our exciting panel discussion, which will be focused on structural engineering trends and new age mounting technology for rooftop solar projects. Here, I would like to make a small announcement to all our attendees. If you have any questions during the discussion, please post them in the Q&A box. Our panelists will take those questions at the end of the discussion. So the session experts who have joined us today are Ms. Azah ma'am from Cover Energy, who is also the moderator for this session, Mr. Harshal Akhori from Stroller, Engineer Malik Newman Khalid from Yellow Door Energy, and Mr. Ahmed Ziada from Danway Electric and Mechanical Engineering LLC. He'll be joining us in a while. So, ma'am, I will request you to take the discussion forward.
Okay. Hello, everyone. It's my pleasure to be here discussing with you about one of the most important and underestimated projects related to the solar system, which is the structure and the mounting structure itself. We will cover some points related to our discussion today, but I want to start with the most excited thing that, from my point of view, related to the top mounted structure. Can we find some tracking system in this regard? What do you think? Rooftop tracking system.
Yeah, shall I take this one?
Yeah.
Yes, why not?
Yeah. So see, like, I mean, as I said during my presentation, that there are a few examples that whereby people have, or the companies have, they have the tracking systems on the rooftop. So first of all, when we are looking into a large scale or a mainstream racking topology, so it should be techno-commercially viable. So let's discuss on the technical part first. That what are the constraints we have, or we face for the tracking systems on the rooftop? So first thing is the megawatt hours generated. Okay, so for example, if we can only install, let's say, 10 kilowatt peak rather than a 100 kilowatt peak system, so it defeats the purpose of putting PV on the rooftop, because if you're not getting the right amount of generation, because you're putting a very small system because of the constraints of the racking system, it is not technically viable. Second thing is the build quality itself, because if you are putting a system on a height, you need to design it to withstand the local winds,
Supporting the load calculation.
Exactly. And then the third thing is that, okay, how many rooftops are compatible with these sort of systems? For example, if it's a metal rooftop whereby it's just a sheet or a sandwich panel, you cannot put let's say, kind of a racking system or a tracker system on top of it. If it is, let's say, facing 20 degrees north, and the tilt of the rooftop is 10 degrees, so it becomes almost impossible to put a tracking system.
That's right.
Okay, so just because of these constraints, we
But
can,
it's feasible. Really, we can find, if we have a hangars or something like that.
Yes.
We
So,
can
for
find.
example, if we have trackers with individual PV modules with a low center of gravity, they are not installed at certain height, and then the fixing mechanism is compatible with that particular roof surface, then I think it's the best case, and for sure it will make economic sense as well.
Okay, fine. It's very clear, and this is a very interesting topic, by the way, to get that tracking system movable parts getting out of roof and generating more energy. This will be great if we keep the borders that you address,
Yes.
the technical limitation. If we solve it, then
Malik ji has practically covered almost everything here,
yeah.
and what makes it even more difficult for a tracker to be installed on a rooftop. Let's say if we take consideration of an RCC rooftop, right?
Ah,
The point is that every single roof has to be assessed before the solution makes it to the market, right? So that doesn't make it scalable. Once a solution is not say scalable, then it becomes an issue for a racking system to think about the product, invest on it commercially for a long term basis, right? So uh, the one thing when he said that when a system is a single module based, right? If it has a certain height, if there are right fasteners attached to it, and if it is at a right height, right? Only then it is possible. So there are a lot of different challenges, right? And there are things that you cannot simply just put solar everywhere, right? There are multiple places that we've been doing, and they have been paying us really well, right? So trackers
yeah.
currently for now, it would be a challenge. Maybe we find a different kind of a module that has a different kind of a shape or a different kind of a system
50.
requirement, or maybe lesser weight.
Other
Right?
technologies
Maybe
will
then
support
yes,
this,
yeah.
right?
Current technologies may not favor.
Yeah, that's lead me to ask you, Mr. Hashal, about the efficiency of the design. The structure will live for all the 25 years for the project duration. So, from the manufacturer point of view, from the solution provider, the design
Right.
parameter itself, the
Right.
effective load that will carry, and the structure itself. Uh, I think this point is a major point to select this type of structure over that. What is your comment on this?
See, for every single roof that is designed for every single product that is designed, it has to be code compliant with the particular local code. When you're
Okay.
going with a particular local compliant code, you're completely getting all the things compliant with your systems. When the systems are compliant, when you check your systems are wind tested, when you check your systems are non-corrosive, when you check that your systems are rated against fire and safety, right? When you see that every other thing is in line with the system requirement, yes,
Of
then
course.
probably obviously you can bank for a system like that, right? But
But there is
you
a
have
general standard for the design. Am I right?
So for every specific region, right? So let's say when you talk about India, right? You don't have to consider snow loading in your calculations, right? When you talk about Europe, right? Yes, that is a factor. So India has Indian standard, Euro has Eurocode, America has X, and Japan has Y, right? So uh, every single system that is designed to cater, right? So let's say I am making the best system here in India, doesn't mean that my system will be compliant,
Yeah,
in Europe as
with
well.
other places, the European
This
or
is
the Mediterranean.
Yeah.
Yes.
So this is probably the biggest mistake the system companies are doing, right? If the system is sustaining for, let's say, 5 years, right, they think that the system is successful, and they implement the same system elsewhere, right? So
Yeah.
that particular region has a different set of requirement, right?
Right.
And it may have sustained wind speeds for a long time, right? Anything can happen. So one must design a system according to the local codes. Only then the system will be compliant. There are n number of uh, Malik has already
Issues and
covered. Yeah,
failures.
already covered all the types of codes that are available, right? 2703 UL is
Right.
there for mounting systems, right? It is for all kinds of clamping and everything, right? 3703 is for your trackers and everything, right? Then there are other material tests, raw material tests, right? All of that is taken care by your factory inspection and everything. So
Yeah.
system has to be as per the local code, otherwise the system may not sustain.
That's right. Even if you keep the same design, I think the environment itself around it, if they have more humidity, more salty, closing to the sea, maybe vessels can make some sort of risk in design. That's, I think, also Mr. Malik addressed something like that related to the quality assurance and the procedure itself during the operation and maintenance. So,
Absolutely, you're right, right. So I'll just give you an example, right? We were doing a
mhm,
project in Oman, right? So
mhm,
Oman has very high corrosivity in the air, right? Now there are categories of corrosion, right? C5 being the highest. In C5 also, there are different types of corrosion. There is industrial, there is marine, right? So all kinds of corrosion activities your the client has to provide, right? A system that is tested when it is in the production phase, it has to be specified that this particular project is going for a certain specific uh, uh, you know uh,
right.
atmosphere, and it has to withstand this kind of salty
And the
conditions,
weather,
right?
the weather, the weather situation, the atmosphere itself
Absolutely.
is one of the major inputs that affect also the design. And
Absolutely.
I would like to
yeah,
just add one point here.
yeah,
Yeah.
Uh, so, So that is, I think, neglected for so long. That once you have procured the mounting system and then you have stored it on the site, so once if you have stored it on the site and you have not stored it properly, so still the corrosion can happen. So the white rust and the red rust, so these are part of it. So if there is no, let's say there is moisture, there is no ventilation, so if you have not stored it properly, so then you're again destroying your mounting system. So that's another very important thing, that okay, if you have bought a state-of-the-art mounting system, but you have not stored it properly, then you have, you defeated the purpose of the whole procurement.
This is a very important point, because from as you yellow door project, I think you cover all these aspects and the projects, and as well there will be a manufacturer recommendation from the other side. We can make both happens to protect the product until it's installed properly and make its own target. Um, Here I will ask you both related the certificate that the mounting structure could have. Even the material can affect the type of the certificate, totally understood. But if we are talking about general international standard or something related to maybe the MENA region, this is a very important point. We need to make the clients more conscious about what they need to ask about, if there is a sort of accreditation from international laboratory or testing agents, and this is will be asked also from the developer related to the warranty that it's covered. So I will keep the floor for you. Mr. Harshal, the manufacturer.
Right. So simply, I would want to say that there are multiple different system requirements and compliances that are required. Obviously, what Malik also rightly said. Storage also becomes an issue, right? For companies that are not producing their own mounting systems in their own country and are importing, right? It becomes a challenge, because your quickest revert gets to you in about, or solution, gets to you about in 3 or 4 weeks time. That's a ship sailing time, right? By the time your project has already suffered, you've suffered 3 weeks of generation loss, right? So all of these things, have to be, I was of the opinion that there should be one global, certification method, wherein, one single certification you get it done, and then it reduces your lead time for your, testing and appliances, right? So every single other, items, whether it is module, whether it is, cables and everything else, these are already tested at the factory, right? These are already quality tested, right? But structure is something that every single time when you are, applying it to your roof, right? Because every single roof is different, right? So you have to go through a certain set of process to get the product approved. If certain X minus Y number of processes are already done, right, you're left with certain number of procedures, right? That will make things easy for you, and at the same time it will help you in understanding that you have delivered a good project. Imagine 10 years down the line or 15 years down the line, right? uh, in the lack of proper technical viability, we installed trash over and we are recycling steel or aluminum, right? It will be a disaster, right? Let's say our population for the world is growing, global warming is a huge issue, right? Weather is changing, right? All the data that we have are based on 50-year return period. All the wind speeds are also as
Right.
somebody said
But
in the
let me address something. What about the material itself, the material certificate? Um, we know that the most famous type of material that used in the mounting structure is the aluminium-based mounting structure and the galvanized steel mounting
yeah.
structure. Are there a certain standard that when you get this sort of material, how we can get some sort of confirmation from the manufacturer in this regard?
So there are exciting materials that are being generated by different companies. There are different types of material coatings that are available with different materials from different manufacturers across the globe, right? So somebody is procuring material, right, from let's say a different country. Every single thing has to be checked at the factory by a third party, so that absolutely lab tested also, right? So that the quality requirement which was approved during the design stage is exactly what is produced in the manufacturing facility. Else, it makes no sense in taking the system from wherever you're taking it. And system has to be third party witness, right? So let's say you're in Egypt, let's say, and you're taking systems from India. There are n number of third party agencies that can be involved and sent to different manufacturing locations that can be checked as per the QAP, right? And the system is then good to go, right? So that is how it's a general process that everybody follows here in India and internationally in order to get these things done, right? Whenever you're exporting material in Africa, right? So you have to get through
Then
SGS.
it's depend on the standard getting in that area and the type of the design itself. This is will all affect. Mr. Malik, do you have any comments on this?
Yes, I'll just add to what Herschel said. I think he described very well. Why we need standards? So first question is that why we need standards? Why there is a standardization of the materials? So what is the intent for all this? So uh, uh, I look at it from a very different perspective. So, for example, if we look at UL 1703, so UL 1703 gives us the guidelines on the fire ratings of the mounting system. And this is a very important concern, especially if you are going for a rooftop solar system. If it is a ground mount solar system, yes, okay, all right, there is the dynamics are totally different. But if you're working on a facility whereby it's a multi-million-dollar facility and your insurance cover is even, let's say, 10% of that facility, so you need to factor a mounting system and the complete system, which shall stand the harsh conditions of the environment, which shall stand the electrical conditions of that particular system, because PV system on a rooftop is a hazard. Okay, unless you protect it with the proper mitigations. Okay, so there has to be a equipment that is rated for that particular facility, for that particular environment. So there are different grades of aluminum used in PV mounting systems. There are different grades of stainless steel, etc. And then, for example, as Herschel said, that there are different certifications for different markets. But in general, this UL 1703, UL 2703, 3703, and 62817 IEC, these covers the fixed tracking systems and the tracking systems.
Right. I totally agree with you both. This is related to the material. This is related to the region that we are working with, and overall, at the end, we need to trust the structure system that will match all the duration with the photovoltaic modules. That's why we need to make sure. And on the other hand, this has led us to talk about the roofing material itself. We are talking about a structure, it will be fixed on certain roof. But what about the roof, the material of the roof?
Mr. Malik, would you like to take
it? Yes.
Sure, sure.
Go ahead.
So it's also a very interesting subject. So for example, let's say we were discussing one project. So there is one of our client which is using a sandwich panel. So in that sandwich panel, there is a special foam membrane, which is like oxygen to fire. Okay, so it is a fuel for fire to happen. If there is something goes wrong, so then you need to properly protect it. So what I would say is, like, I mean, in a nutshell, in a very brief way, that fire can happen. Okay, so there is no way we can stop fire, irrespective of whatever is the roofing material. Okay, so but we can mitigate that fire with lots of proper mitigations on the electrical side, on the material side, and then choosing the right materials and choosing the right HSE. For example, if we are using a PV module which is a fire spread of, let's say, 3 meters, and then versus if we are using a PV module which is a fire spread of just 1 meter. So that can greatly reduce, the risk of this thing. And then, for example, if we have skylights on the rooftop, which is a fiber skylight or a plastic skylight, which is again a fuel for fire to happen. So if there is any fire, this skylight will catch fire and it will, help burning the facility. So we need to look at materials which are, let's say, resistive in nature to fire, which are the system is designed with the proper mitigations, and there is a proper control policy. There is a proper monitoring system which is surveilling the system all the time.
Then can you make your recommendation to your clients that this rooftop material is not that healthy environment for the system? I suggest you to change from this to this. The design team will make their recommendation, and this has happened, or you will make your own preparation for the site, and if the client refuse to make the changes or the upgrades, what is the best way to deal with this situation?
So for the newly builds, if the client understands, he listens to us, and then we can work out ways in a very price effective manner. But if it's a retrofitting, then unfortunately we don't stand a chance that okay, all right, we can change the roof material. So then we need to put the proper mitigations, proper solutions. So I mean, I'm into this solar field, and we are working for the last 10, 12 years. And if you look at the probability that okay, all right, how many plants caught fire, it is very less. So that's a good sign for the solar fraternity that okay, yes, we guys are doing good, and we are installing something which is which is feasible for the sites.
But HSE precautions is necessary.
Yeah, HSE we emphasize all the time that this is very, very important. Putting a PUI system, it's not that, let's say, difficult. Yes, okay, all right, you can put it, but if you have to maintain it, that's the real thing.
Okay, I will forward this question to Mr. Hasham. This is related to the can you be a source of fire by the product itself? How you can make the interaction between the rooftop material and the structure itself. I know there is, by design, there is a spacing between the structure itself, and the installation progress will address that amount of spacing. But what if we have some sort of fire from a manufacturer point of view? Can you imagine such a situation, and tell us what we can do?
Those spacer and all types of HSE requirements need to be fulfilled, because if a structure goes right, it is a very highly conductive material, right? It catches fire, then there is no stopping, right? Spacer materials, right? The material is protected with a breaker is put between let's say rafters and your purlins, right? So that the electrical conductivity does not seep through, right? So, but these are certain design aspects that you take into process, right? If system catches fire, right, and the design part or the HSE part is missed out, let's be very let's face it that the system will catch fire, and the steel or aluminum will help propagate it.
I know that the probability is very limited in this regards, but look, my mentality related to the operation and maintenance all the time. So I'm thinking of the worst case scenario, because if we
See, there are
ourselves,
obviously solutions. There are obviously solutions like there are certain types of polyurethane painting that you can do, but
it will
obviously,
be a special requirement.
yes,
Then
that's a
it will be
special
a special
addition.
order.
Special addition to the coating of the existing system. Now that is something which may or may not be acceptable to the customer, right? Because it's an additional costing for something that they're predicting might go wrong. As I say in my meetings, that prepare for the worst and then deliver your best, right? So this is something that one cannot always be prepared for. You cannot simply just put a polyurethane coating of let's say 200 microns over all your systems, right? For aluminum it will not be even be possible, right? You would need hard anodization on that. But having said all that, you have to work out on a series of steps to ensure that the system does not catch fire. System can catch fire from inverters, right? You cannot design a mounting system that when inverter starts, catches fire, there will be some kind of extinguishing that would come into play, right? System alone cannot do it in itself. It can protect itself, but for only a certain amount of time. But that cannot be set as a rule.
Okay. I totally agree with you that if there is a special requirement, we must match it with a certain type of coating material. But this is reverse me back to the design stage of
Right.
selection and spacing the structure itself on the rooftop. And from your experience, both of you are well known in this area and making such a huge project. If I am talking about hangers, especially, what is the best space that must be part of the design or the designer thinking that this will keep the ventilation on the pack module with a certain amount, with a good amount, and will keep the efficiency of the levelized cost of energy related to the price of the structure itself. So I need your comments on this.
So, okay, Malik, you can go. I'll follow
No
up.
worries, you can take it. I'll take it last.
So, any system design that we have a varied climate here in India. We have really hot, we have really cold, we have literally any kind of weather here in India. But there is a certain standard that we have adopted wherein we put our modules lowest part of the module frame, and between the crest there is always a 100 gap, right? So there is certain ventilation that is always there, right? It is absolutely different from cold countries where they are using 30 45 this thing,
But
right? So
I think we are talking about the more toward hot climate.
yes,
That
so
the effect will exaggeration. We will
so yes,
see.
at the peak hours during 2 to 4, right? The heat generated from, let's imagine a tin shed roof, right? An industrial shed roof, wherein your industrial shed itself is heated. There are modules that are heated, and your operating temperature can go from 80 degrees to 120 degrees as well, right? So that kind of ventilation for a stationary system, right, can only be mitigated through certain this thing. And considering 100 is as a base standard, I think that is justified. That is just one part of it, right? Apart from when you're designing a system, you look at the worst condition, you look at the worst wind speed, you look at the worst ever possible case scenario, case study for a
Yes.
particular region, and then you start building on that, right? You see a system, an existing successor that you've made, right, predecessor, sorry, and then you prepare a system that is ready to take on all the challenges, right? Because see, if you talk about the recent changes for the past 1.5 years, there have been larger size modules, right? So there is limitation for let's say government buildings here in India do not allow more than 60 kg per square meter of loading, right? When your module has
Right.
increased from 21 kgs to 28 kgs, obviously it has increased, but the same mounting system is being repeated over and over, right? With the same wind speed, without taking care of all of these things, right? So there has to be proper check from the client side as well, right? Not to understand what the supplier is pitching it to them. For a supplier, it is easy. You don't have to invest into a new type of product, right? If the clients are aware, right, they would demand from the supplier to give them the right correct material, and this is when people will start innovating. When they start innovating, beautiful things happen.
Okay. I want to hear from Mr. Malik also.
Yeah, I think Harshal explained it very well. So see, there are different mitigations which we can perform, and these mitigations, like I mean, they are based on experience. There is no, let's say, study behind this. So first of all, I'll just make it very clear. So
That's
first thing
right.
is that the space between the PV module's back sheet and the crest of the roof sheet is, as Herschel said, 100 So we usually, like I mean, prefer that it shall be between anywhere between 90 to 140 So that is the range where we work at. And then again, it depends on the nature of the client as well. So for example, if it's a warehouse, if it's a simple hangar with which has proper ventilations, they are not doing anything. There's not much industry work going on. Then okay, all right, we can live with 100 or 110. Okay, but if it's an industrial environment where they are generating some sort of heat, there is some exhaust, there is some other things. So then for sure we need to look at it from a different perspective and maintain at least 120 to 140 mm. The other thing which we can do while we are preparing the PV layout is that we should keep our tables, PV shade tables width not very much long, so that we can allow for proper ventilation. If the table size is too huge and you have crowded, let's say, 10, 20 panels together, or let's say there is like, let's say, a table of 10 by 80, 10 by 8 panels. So there are 80 panels in that one table. So maybe we can minimize that table to 8 by 8, right? So that we can allow for, and then after that table, we allow for a proper aisle for wind ventilation. So that will also minimize, and then that will create the let's say it will ease out the PV modules. That, for example, here we have noticed that the cell temperature is, let's say, 80 to 90 degrees Celsius, or let's say it ranges between on average 75 to 80 degrees Celsius, which is like huge. Okay, so it can result in any cause of fire. So these are the recommendations which we suggest.
So we are talking about our first enemy, the temperature. There is many statistics, which is get how much heat trapping due to that very small displacement between the structure and the, the rooftop itself and the PV panel. We are talking about increasing in panel temperature of more than 30 to 35 degree, which leads to a major drop in the power itself of the panel. That will lead me to the point which is related to the cost, the pricing, and forecasting for the pricing. How can you evaluate the price of the structure itself? I know it's varies based on the design, based on the material itself that's used, but we are talking about a 8% that the structure is representing for per each kilowatt hour. If we can use such a representation for the pricing, what do you think the near future and the far future will give us in this regards? So, Mr. Hashal, you can give us your opinion.
So current, past 1 year has been very tough on everybody in this steel metal market and whenever you're pressed against a wall, you start to innovate. We are, anticipating people would come up with, innovations in order to meet the requirements, right? Tariffs have already gone, so low that, it cannot drop further, but they won't even allow you, better, working rates, right? So the only way about it is to design systems efficiently, and that's pretty much about it, because the steel is going to, stay the same. This will be the new normal for the considerable part of next year, and
But we are talking about average situation that you can make a stable design between all the competitors, and
so yes,
at the end we are talking about. I know this is related directly with the material pricing and the material market itself. So, but what do you think? We are expecting an incremental in the price, or this is not very close?
So for a general consideration, right? So for any company, right, what we do is we check for a requirement, we design the system, we check it, and we get it implemented, right? So everything, works out on scale, right? Even if, you're doing, a certain X number of things, right? If you're able to add, Y number of things to that, right? The cost of you still make a good profit, but you give lesser number of costs because of scale, right? So that's something, a stable, suitable design is something that is going to be, uh, uh, driving
Affected.
costs down, right? However, situations on different countries, protecting their own manufacturers will relax in the coming future, wherein countries will be able to trade with with much freedom, and then obviously all these prices will I am very hopeful that the prices will definitely come down, and people will start to innovate.
Okay. Then what about the supply chain issue? Can it affect directly the pricing?
Supply chain, yes, it is whenever there is price pending to be on the rise, your material stockists, they store the material does not make it to the market because of the lack of the material, the prices
It's
go up.
increased. Yeah.
Right. That is one part. The other part is because of the increase in the raw material, because of the many units in UK have still not been fully functional. Right.
Okay.
So the demand is more, right. Everybody has to go green, and everybody has to make their own systems requirements and everything. Right. So
Right.
all of this will pan out well with workable time. You have to give
But
it
you
time.
are optimistic.
I'm very much optimistic. Prices will definitely, because in India, we have been fighting, at every single cost. India is a very competitive market, right?
Right.
So
That's why
you
I'm
do nothing.
asking you specifically.
So yes, so what we do, we have been innovating from system day one, right? Even during the lockdowns, everybody was bang their heads, requiring for a new solution, new types of fixing arrangement that would reduce obviously the cost, right? Either the cost,
Yeah,
upfront capital
this
cost.
is can drive the market itself. What happens in the market will be reflected directly on the pricing of the component, and
Absolutely. I mean, cost
that's
can
very
be
clear.
a variable of two things: your capex cost on the material and the installation cost, the service cost. If you design a system, right, that is very easy to install. Two people can install, let's say, 100 kilowatt a day. What's the problem? I mean, you at the end of the day, you are saving cost, right? So think out of the box. There will always be a solution.
Mhm. And I wanna hear from Mr. Malik also, as a developer and EPC contractor, or some sort of financing solar project. What do you think about this issue?
I think this pricing topic is very very tricky because at the moment we are facing a price hike for each and every equipment. So be it cables, be it mounting system, be it solar PV modules, be it any raw materials, uh, and we also foresee that in the next year things will ease out and we will have something which is, let's say, uh, bearable for the clients, for the developers, and for the EPCs as well. Because at the moment, even if we do a very very state of the art design techno commercially, still it is not viable.
It
Okay,
is
so
not, no.
you cannot, find the tariffs which the client is looking at, the tariffs which we used to enjoy in 2019. We cannot do it anymore for the last 1 year, this year, and I think in 2022 won't be much different. But I think by Q3, Q4, 2022, things will get a bit easier, but we don't see much change in the next few months.
Then, as a conclusion, we are talking about some sort of stability condition comparing to 2021 during 2022, maybe. Then we will face the same pricing range for the overall component, especially the
Correct.
mounting
Yes.
structure. And we are all optimistic to recover and get back to to the situation which is where used to have and used to get pricing over it. Um, and I have a small comment related to the structure itself. I think, from my point of view, because of the project that I'm working on it, that this is the least part that has a major problem, by the way. If it's a well designed and well installed and the material selection was good, the coating itself it's well prepared. But I want to have your comments about the major failure that can be faced dealing with the structure. If I'm talking about tracking system, where we have a mechanical part and movable part, and the probability of the failure will be increased, and the fixed structure itself. So I will keep this question as a closing question, and we will receive the Q&A answer questions from the attendees after your answer.
All right, sure. So first thing I would like to highlight here is that, yes, okay, all right, if the mounting system is designed properly, it is calculated properly, then only it will not fail. So we have seen in the past that if the structure is not designed properly for the climatic conditions, for the load bearing capacity, for the wind speeds, etc., so the structures will fail. Okay, so that is one cause, the major cause of it. Second thing is that somewhere, for example, in UAE, if you are doing projects in Dubai or the other Emirates, or if you, let's say, for example, you're doing projects in Jordan or somewhere in Pakistan, close to the sea or the coastal areas, or whereby the humidity is so high, then we see the issues for the corrosion. And the second thing is that specifically for the ground mount systems, we need to understand that we need to see the soil condition as well. If it's corrosive in nature, what sort of soil is that? So we need to properly size the foundations. We need to properly do mitigations for the foundation so that they are not corroded, and the steel structure as well. And then somewhere we feel that, for example, the bonding on the PV modules, it will fade away with the passage of time if we have not used, proper gripping tools or the proper pinching tools or the proper bimetallic lugs. So that is another issue which will, result in later on galvanic corrosion, or let's say the erosion of that steel structure.
Yeah. Okay. This
Pretty much.
sounds logical. Yeah. Yes, Mr. Hashab.
So, Mr. Malik has pretty much covered everything, summed it up very nicely. And for ground mount systems, there is certain issues that we don't foresee while designing. Is, let's say, if it's a soil driving system, right, and let's say the salinity of the soil is high, right? We don't understand the degradation of the soil and how much it will, impact the material inside the soil, right? So these are small little things that obviously, while taken in the design part, there are obviously multitudes of things that I may have missed out, right? But these are small things that make a mounting system more stable, more reliable, right, and more open to invest on it.
Yeah. Yeah, that's right. Then we need to think more about the investment. We will put our money to get the best results. At the end, client satisfaction related to the amount of energy, the quality of energy that he has, and the service level agreement, which is the SLA repeated failure that's happened on site. This is all affect the client satisfaction at the end. So. We are looking for more energy. We are looking for more productivity of any system that will lead us to be very clear in each detail, design procedure, installation procedure, and all the aspects around. From my side, I wanna have I just opened the Q&A panel, and I will let this mission for Anand. From my side, I want to thank you. Thank you, Mr. Malik. Thank you, Mr. Hashab, for these valuable inputs from your side related the rooftop mounting structure. And from my side, I would prefer to see that tracking system all around on the rooftop. And it's a pleasure of mine to be with you. And
Thank you, Azza.
Thank you very much, Azza. It was a pleasure.
Thank you.
Thank you, ma'am. So we have a few questions. I'll just show it on the screen.
Yeah.
So this is from Alexa.
All right. So I think the short answer to this is, or let's say the practical answer to this is no, because there are certain adhesives which people have used. So, for example, if these adhesives are in a very strong environment where the temperatures are very, very high and the melting point is very, very high. So I prefer that, okay, these systems shall be connected properly using some, drilling mechanism or some fixing mechanism other than the adhesives. Because the adhesives, they are not recommended. They will, turn off in the next 1-2 years, and then you need to relook or refix the PV system.
Right. I would like to also add to this
Yeah,
the
sure.
the principal application of adhesive is you have to graze the colored part of the sheeting in order to get through the metal part, right? Because the material adhesive is only applicable on the metal part of the sheet, not on the painted side of the sheet. So you buff the material of the painted side. So there are two possibilities: you over buff it, right? When you over buff it, there are chances of leakage at the time of installation itself, right? When you under buff it, the warranty for I don't know if they cover the warranty, but the warranty of the methodology is not applicable. So your system is going for a toss, right? Having said that, you are not getting the system installed by an engineer. It is the workman that is going to do, right? And they have a certain number of targets of brackets to be done. So the installation in itself, the procedure, right, is not foolproof unless and until it is backed by a warranty by the people who are providing the adhesive solution. So from my side as well, it's a strict no. But this is a trend here in India. If there is a sheet that cannot be installed without drilling, it has to be a high seam roof, any kind of your Proflex roof, your Calzip roof, or anything, any kind of seam roof, right? Trapezoidal roof or trapezoidal roof, I myself personally do not recommend any kind of drilling. No, sorry, any kind of adhesive.
Thank you, sir. So, another question, I'll let you know. Basically, the question starts from here. In corrugated roofs, solar mounting application, do you use steel structure or you prefer using aluminum? This is also
So
to Malik, sir.
yeah, so like most of the time, or you can say in general, we'll use aluminium. So because of the properties of aluminium, so first thing, it is very lightweight. So on the rooftops, we don't want to put lots of weight, because anyways we are trying to minimize the weight on the rooftop, just not to damage the rooftop and to have a proper structural integrity of the rooftop. Second thing regarding is that we also check the roof material, what sort of roof material it is. So to avoid any source of galvanic corrosions. So we always prefer aluminium structures with proper EPDM paddings or any foam things, so that there is no galvanic corrosion between the aluminium structure or the steel structure or the roof sheet. So the answer is mostly we will go for the aluminium structures.
Thank you, sir. So, this is another question that has come.
Why the lasers on the backside of the yes, all right. So yeah, as we said before, that mostly we are keeping a gap between the roof's back sheet and the crest of the roof, and in the crest of the roof sheet, a minimum distance of 90 to 140 mm. Depending on where you are installing the system, it's a very, very hot environment, like for example in UAE. So I prefer that, okay, at least a 120 to 140 mm gap shall be maintained between this thing. So configuration of roof tiles. So I'm confused here. I think it shall be a roof sheet, because roof tile, maybe it is for the flat rooftops, flat concrete rooftops. So I'm not sure if it is in relation to a flat rooftop system or a tilted rooftop system. And then fire. So the closer the module to the sheet, there are chances of fire. There are great chances of fire, because the temperature between the back of the PV module and the roof sheet will be very, very high. The other causes of fire can be, there's an earth fault, there's a leakage current, there's an insulation loss, there is a short circuit. So that can also help fires to propagate. So the chances are very high. So we always suggest that there should be a minimum gap maintained between the panel and the roof sheet. Plus, what I also suggest is that the PV system's table size shall also be, designed in a way that there is maximum allowance for the backside ventilation.
Thank you, sir. Harshal, sir, do you want to add something?
I think this is pretty much we have covered this during our discussion.
I think this is the last question we're taking.
mounting clamp? Is it
I think this is based on the OEM's recommendation. So we always recommend that whatever the PV module OEM is saying. Usually they ask for these 4 clamping points, and then they have suggested the clamping points as well. That okay, how much distance you need to leave from the top and the bottom. So we always recommend to avoid any warranty issues, to avoid any installation issues, to avoid any deformation of the PV module's frame. So we always suggest that follow the OEM guidelines.
This is the same. I mean, the module comes with your module installation guide. In every module installation guide, you will find a clamping distance. For some modules, it is available on the longer side of the module and also on the shorter side of the module. For some, it is only restricted to the longer side of the module. You have to just check wherever your clamping distance should be, where your clamp should be, where the clamping distance are recommended by the module supplier, so as to keep the warranty.
So thank you, sir, for answering the question. So we have almost end of the time. So I just like to get few like summary from of this whole discussion from both of you. Harshal sir, you can go first.
I think we one should look forward to designing a system with regards to all the kinds of local parameters present. When we talked about local parameters, so there is Underwriter Laboratories UL that has classified almost everything under one belt, right? We should push towards making it a universal rule for every mounting system supply all across the globe, so everybody follows the same thing. Obviously it has a certain capex attached to it that can be discussed later on. It's not something which is a huge cost associated. There are different points of discussion regarding the trackers. Current technology does not allow, right? Yes, for specific few projects, it can be done, right? With certain different, tweaks with every single mounting system. But tracker on a rooftop, especially flat roof, it is not validated for industrial roof. It is not something which is advisable with the current technology. Maybe future things will change. Selection of material, selection of the type of solution that we're looking at should also be both ways. It should be also from the client side. It also should be from the vendor side. When the material reaches the site, it should be properly inspected so as to have no issues at site, right? And talking about everything, see prices coming down. Not exactly. Structures will be at the current high, right? And with the demand picking up, currently it might also increase. But I'm hopeful towards a better working, and this will help developers take a lesson where they don't need to go so low with the costing, so that the project becomes non-viable in approximately 3 or 4 months of time, right? So that's pretty much about the discussion that we had from my side.
Thank you, sir. Malik sir, you can also.
Thank you, Anand, for the question. So what I will say is that stick with the basics. Don't over-engineer anything. So just stick with the basics. Basics. Check the local climatic conditions. Check your system design. Check your requirements. What is your wish list? What is your client's wish list? And work around that, and then find out ways that okay, because not everywhere 1+1 is equal to 2, right? So you have to see ways whereby you can do some improvisation, just put your thought again and again into what you're doing. And what I always say is stick to the basics. Don't over engineer it. Keep in mind HSE, keep in mind the proper tactics, how you can modify your system design, how you can build a system which is operationally safe, which is generating the right amount of energy, which is not underperforming, which is not a hazard for the people working around it, and for the facility itself.
Thank you, sir. So with this, we have come to the end of this virtual conference. Thank you everyone for extending your time and support for the event. A special thanks to our partner Stroller and Sir Energy for extending their immense support to organize this event. Thank you very much to the experts for this insightful session, and a special thanks to Azam ma'am for wonderfully managing the discussion. So with this, we promise you to come back with more exciting topics very soon. Thank you. The floor is now open for networking. Thank you very much.
Thank you very much, everyone. It was a pleasure.
Thank you.